Okay, let's jump right into biochemistry and the genetics. First off, we are going to need a very important gene called dihydrofolate reductase. And this gene is used for a plethora of biochemical reactions inside of our body. That dihydrofolate reductase, folate, vitamin B9 is huge in biochemistry. Okay, so I'm going to write this at the top. We're going to start with dihydrofolate reductase. That's right up here, dihydrofolate reductase. And what I'm going to do is, whenever we encounter a gene, I'm going to put a box around it. So I'm going to go ahead and do that here with dihydrofolate reductase, just so that we remember that this is a gene, okay, and just not a cofactor. Well, now we're going to need a cofactor to go into this equation with us, and it's called tetrahydrobiopterin. And we just sign with that as BH4. All right, so we're going to take some BH4 over here, and it's going to go into this equation. And then right here, we're going to start with our phenylalanine. Okay, that's our amino acid. So let's go ahead and write phenylalanine up here. Start at this side. Phenylalanine. Okay, and then we're going to have to break this down, because here's what we want to do. I'm going to write the end product down here. We're going to write the end product of serotonin down here at the very bottom. Okay, this is what we are wanting to get. Okay, serotonin, that's very important. So, all right, so we go from phenylalanine, then what do we break it down into? Well, phenylalanine needs to be broken down into what we call tyrosine. Okay, so we're going to do that. I'll show you how that's done. Tyrosine, all right. So we've got a couple of genes in here. So we have a phenylalanine hydroxylase, which is PAH gene, square, which is going to give us tyrosine. Okay, and then we have tyrosine over here on the left side, and then we're going to break tyrosine down. Okay, so we have tyrosine hydroxylase. We break it down. So now we have phenylalanine. We've had genes that we use that encode enzymes to break these down. So for instance, if you look at dihydrofolate reductase, you think, now isn't that an enzyme? Well, that's the gene that encodes the protein to make the enzyme dihydrofolate reductase. Okay, just to give you an idea. In biochemistry, whenever we use the word an "ase" at the end, it is breaking something down. Okay, it's an enzyme, enzymatic reaction. So that's what we're looking at. So here you see where we're at so far. So we've gone from phenylalanine to tyrosine. We're going from tyrosine using tyrosine hydroxylase to get to something very important. And a lot of you have heard of this. It's called L-DOPA. L-DOPA. L just stands for levorotatory, and in the body, all biochemical molecules reflect back under non-polarized light as a levorotatory or a counterclockwise motion. So that's just why they use the L. Okay, L-DOPA. All right. Now there's a pathway where L-DOPA is going to go in and make dopamine, and we'll make a video about that later. So we're still not done yet, because we're still not down to our serotonin. Well, let's do this. Let's go ahead and break tyrosine down, and let's break it down to tryptophan. Okay, and we're getting closer with this, okay? And we've got a gene that we're going to use to break the tryptophan down into what we call 5-HTP, okay? 5-hydroxytryptophan. All right, now we're getting closer to our serotonin, but we're not there yet. What do we need to do next? Well, we're going to break this down one more time. But how are we going to get from tryptophan, 5-hydroxytryptophan, down to serotonin? Well, we have to use one more gene, okay? So let's go ahead and put that gene up here. We're going to put the DDC gene up. This gene encodes an enzyme called DOPA decarboxylase, okay? Now here's what's going to happen. This is an important step, because we're going to take this 5-HTP and basically turn it into serotonin. But I'm going to show you the biochemical name for the serotonin, okay? So the DDC gene, so we have 5-HTP. The enzyme from this gene takes 5-HTP and makes it 5-HT. So 5-HT. What in the world is 5-HT? Well, 5-HT is 5-hydroxytryptamine, okay? So what the DDC gene does is it takes a carboxyl group off the 5-hydroxytryptophan, takes the carboxyl group off, and makes it 5-hydroxytryptamine, okay? So we can write that down. So we have 5, we're going to write the hydroxy, hydroxytryptamine, T-R-Y-P-T-A-M-I-N-E, okay? 5-hydroxytryptamine. And this is the real name of the neurochemical in the brain that we call serotonin, okay? 5-hydroxytryptamine. So when I'm studying biochemistry and we come across 5-hydroxytryptamine, I know that they mean serotonin, okay? And now you know it too. It's very important. Now, here's what's key. We have to have these genes working correctly. And if those genes don't work correctly, then we're not going to get to an efficient amount of serotonin. We're going to stick with serotonin since that's kind of universal for 5-hydroxytryptamine. We use serotonin for that. So to get to serotonin, this process all has to take place. Okay? It's just not some magic thing that the brain produces and doesn't need any help. There are a lot of steps in this. Just like baking that cake or that pie or that gourmet meal, there are a lot of steps. There's main ingredients, and then you have what we call cofactors, okay? The things that really just make it all kind of work out together. So we've got to have cofactors to make this happen. And we talked about one initially, the tetrahydrobiopterin. That's one of the main cofactors. But, you know, we have other cofactors in here as well. You know, to make things work, we need what we call methyl groups, and we need magnesium, and we need folate, we need calcium. We need a lot of other cofactors to make these happen. And if we're not getting good serotonin, we can add cofactors to your biochemistry to help this process work efficiently, okay? If you have a problem with these genes or these enzymes, you were born with that, okay? It's just the way it is. But thanks to 21st century medicine and genetics and knowing biochemistry the way we do, we can add things to your symptom or condition to help alleviate that symptom or condition, okay? And I'm telling you, folks, when we do the biochemistry, we're not talking about getting a pharmaceutical medicine in your body to change things. Because I'm here to tell you, if you look at any biochemical process, there is not one process that says you need a medicine made from Eli Lilly. You need a medicine made from Merck to make this pathway work correctly. It's not that way. It's all natural biochemical cofactors that you have to make things work. So I just want to kind of get that in your mind of going, you know, I'm not shooting these videos to teach you this stuff to go, oh, you need a different medicine prescribed to you. Nope. We're getting down to the bare bones of finding out why you feel the way you feel. You know, the way you feel, there's a name, there's a symptom for it, and they try to cover up this symptom. Let's just get down to the bottom of the problem. Okay, here's your answer. This is what you've been looking for 2 months, 6 months, 6 years, a decade, 2 decades. Now we can do it. Now we know how to take care of these situations, okay? So if you have any questions, don't hesitate to email me ever at drcarter720@gmail.com. I'm going to put all that stuff at the end of the video. You can get my contact information or whatnot. And, you know, if you never get your genetic testing done, you're never going to know the reason why you feel the way you feel, okay? And that not only goes for depression, anxiety, mood disorder, schizophrenia, that goes for all kinds of chronic health conditions. People that have autoimmune conditions, lupus, psoriatic arthritis, you know, Hashimoto's thyroiditis. These things can all be found out. Chronic immune deficiency problems, people that just have no way of understanding why they feel the way they feel because they've been sent to this doctor and to this hospital and this medicine and no one can find out why, okay? How about your genetic testing? Let's, you know, unlock some things here that nobody's looked at it. And, you know, I'm passionate for it because it changed, you know, part of my daughter's life 7 years ago Because if it wasn't for genetic testing, we would have never found out what was wrong with her, because we had been to the experts, okay? And the experts could not come up with a reason why she was having the situation that she was having. And we went to some really good experts, okay? They told us the same thing. And they just couldn't explain why. We don't know why, but take this medicine, it'll help. Man, it helped a little, but not very much. We got genetic testing, and we found out exactly what the problem was. And we overcame that problem pretty quickly, and it changed. She didn't have these symptoms anymore, and she hasn't in 7 years. So that's why I'm passionate about this. You can say you've been to every professional, and they've done every test on you. I've heard that so much. They've done every test available on me. They've never even heard of these tests. They've never heard of the genetic test like this. They don't know what a single nucleotide polymorphism is. They don't know how to get the genetic testing or know the biochemistry behind it to associate that with your physiology to get to your symptoms and then help you. Okay. Questions, comments, concerns, shoot me an email. I'm good for it, okay? Thanks for tuning in. I'm not going to stop till people understand, no, their genetics is behind a slew of the reasons why they feel the way they feel. And we're just going to keep shooting videos associated with symptoms and conditions and diseases and problems and explain it to you biochemically and genetically. Thanks for tuning in. Take care.